We started again.
That's okay.
Yeah, thanks, Julie. Yeah, just underscore pass. I mean, that's a great. If you've never been there, it's really worth it. So if you have some training budget that you can, spend on something like a conference, it's worth it. This year it's going to be out in Seattle again, so we have a great representation of Microsoft, the actual, folks that write the code, guys that have to deal with customer problems. It's really well done, so definitely give it a shot. Find my power presentation here too. Right, so today I'm going to discuss the SQL Server table partitioning feature. Table partitioning has been around for quite a while, since SQL 2005, and it's really great for being able to manage really large tables. You can address issues like, having a table, like normally to build a clustered index, for example, you need to have 120% of the table size re-spacing your database just to build a clustered index. Well, with partitioning, you can greatly mitigate that because you do these. So basically, it's partition level across the. So it's really a great way to make basic data management. I don't think data like to do by like these relations. So today I'm going to review the table partitioning concept and the corresponding technology, some common use cases for partitioning. Essentially when two partitions, this is importantly when not partitions. How to plan for partitioning. The key point there is that tend to partition large tables. Large tables are really unforgiving. We have billions of rows in your table, and you make a mistake, undo it, takes forever days and so. And then finally, I'll show some partition management that you can use to automate, like sliding windows scenarios or merging old data, that kind of stuff, so that you don't have to, spend, take some time out of, 1 week or a month or a day or whatever to do the partition management. Unfortunately, I don't have as many demos as I would like because I have a lot of material to cover, but I will have one at the end of the presentation. To review the partitioning concept, well, first of all, let me ask, how many people actually use partitioning today in production? I only counted 3 hands. You got a kid. How many people running Enterprise Edition? Much more? Yeah, it's kind of out of sight. Usually a lot of people have at least one instance of Enterprise Edition hanging around, but partitioning is strictly a SQL Server Enterprise Edition feature, of course, developer as well. It's not available for Lesser Edition, and it's not available in Windows Azure SQL database either. However, the main use case for partitioning is the real big stuff. Just chances are you got a lot of that on the front. So, one key point is partitioning fundamentally affects how the data is stored and how the storage engine, how the data sees the data. It's a lot like a index in a way. It's like the way a clustered index affects how the data is organized. Partitioning is just one layer on top of that. What it actually does is it segregates or segments the table horizontally to multiple, independent structures that can be accessed as a whole just by accessing the table. But each of those independent partitions can be managed by itself. Like you can rebuild a specific partition of the specific index without affecting any of the other indexes or partitions on the table. There's a lot of cool stuff you can do because each partition is independent. However, the metadata is shared. There's only one schema associated with that data. And, so therefore every partition of a given table index, it all, has the same schema for that data. Most people don't know this, but SQL Server tables have been partitioned since 2005. The only real difference is that, SQL 2005 and beyond, the non-partition tables, just like you see with the great tables, are really just a single partition without any boundary. But you can still do some limited functionality on the table, even without a partition. This is the diagram I stole off the book online, which just kind of shows the organization of a table, and more specifically a table that can have multiple partitions. And then as you can see, like every partition is an independent, super B-tree structure, along with corresponding, data rows, row flow, bottom data stuff. So really, the idea is that you can have one table that queries just access just like a single table, but underneath the covers are multiple partitions. The beauty about partition, or one of the beauties, I should say, is that it gives you more granular control over the physical space. As you probably know, really all you can do is specify an on clause where you give the name of a file. And if you don't specify an on clause, they just go to the table, gets created, and the default file. But with partitioning, you can actually control that more granular in the sense that you can have a single table and have different partitions of the data distributed among different files, certain cases. Some cases that's useful, some it isn't. This depends on your specific reasons for partitioning in the first place. And just to get on my soapbox a little bit here, I know a lot of people I've seen try to jump into partitioning a table just because the table is big, like has billions, and all that, with the expectation that that's somehow going to automatically improve performance. It doesn't by itself. I mean, indexing and query tuning is really the key to performance improvement, not partitioning itself. What partitioning does bring to the table, though, is a lot of manageability. So that's really the main use case. Typically, when you partition, though, you tend to partition the objects the same way. In other words, you could theoretically partition a table differently than the indexes on that. But most commonly, one partitions the whole table and its indexes using the same sort of partitioning mechanism, so that all the data, for example, for a given date is in a given partition, or all the data for a given region is in the same, because that provides some additional capabilities that I'll discuss in a few minutes here. Some of the core concepts here that a partition, or I'm sorry, a row exists in exactly one partition and only one partition. It doesn't like duplicate data at all. You can manage the partitions individually, like I mentioned earlier. This is a very large table, and I also mentioned it's only available for enterprise and development. There are some limitations. You can only have 15,000 partitions per table, which is frankly plenty in most cases. It sounds like a tremendous amount until you figure, well, I got 20 years of history. I want to have daily partitions. Well, blow it out pretty fast. But that's really a relatively recent development. Before SQL Server 2012, you had to install Service Pack 2, which is 2008, in order to get 15,000 partitions, and even then it was a configurable option in the database. There's a sort of procedure called a CDF, increase partition, that allows you to increase to the max of 15,000. But if you haven't done that and you're running the older versions of SQL, like jumping up to 1,000 partitions, as well as 2005. Now, partitioning is pretty much transparent. It's all query, so it's really seamless. That makes it easy to migrate to a partition type table structure without even touching the app. SQL Server is partition aware. Before SQL 2008, SQL Server would actually include partition elimination in the query plan itself as part of the operators in the query. It would really just generate a list of those partitions that might be touched by a given query, and then do a nested loops operation to actually access individual partitions. With SQL 2008 later versions, they push those kind of smarts down to the storage engine. So the storage engine itself accesses the individual partition much like it does an index if they have the index count in the higher part of the key. So it's almost like an index C logic. So at least it's a little bit less visible for you to manage this. You can have certain DDL operations that operate on digital partition, which is one of the big benefits. And you can partition on a single column, SQL Server table partition. And any column except those listed up there, mainly the big mod data types or a timestamp, it can partition on any other column but those. So it really has scalar value. In my experience, the most common use case for partitioning is this is either a date or date-time column. So it's relatively beneficial to partition on another value of our use case for that. So for example, if you have, let's say, some sales, they have a dozen regions across the country, and you do incremental load, so such that you can DL process to load sales in one of those regions. You can use like list partitioning techniques to do the DL process in such a way that you update or switch in incremental loads to the individual sales for a given region without touching any of the other data in the table. And that's kind of cool. But like I said, the most common case in my experience is the date time. SQL partitioning is natively ranged partitioning, meaning that every partition has a lower and an upper boundary, and any values that fit within that boundary get placed in that partition. The lower boundary of the first partition of the table and the upper boundary of the very last one is infinity, meaning that there has to be a place for every row. So, you can't have any rows outside of the range of what's considered the table. It'll definitely be get the highest possible value on the last partition and the lowest possible value on the first one. I mentioned list partitioning, briefly a minute ago, like using that sales example. A lot of times, if you want to go down that path, you can also put a check constraint on the table, just to make sure you don't have, some unwanted regions, or ones that you didn't expect to get stuck into one of the partitions. Without that, it'll just be a range. So if you have regions of, let's say, 1 through, that's kind of a bad example, but even number of regions of 2 through 24, and somebody comes in with 2 in between, it would end up in, you have multiple regions in the same table. You can do hash partitioning as well if you were to partition on any persistent column that would materialize a hash value, like a module or something like that. But frankly, that's not really a good use case for partitioning, in my opinion. Simply, people call it sharding data. If you want to do that, you ought to be using you ought to be using Field Data Warehouse. I mean, that's more the purpose of hash partitioning. In the case of the standard relational engine, hash partitioning, all it's really doing is moving data, partition. But the question is why you want to do that. Does anybody try to do that or does do that? Yeah, like I said, it's generally relatively rare, but I have seen people go down that path. But there needs to be a good reason. And I'll get back on my soapbox here. I'll say, before you partition, understand why you're partitioning. It's not just going to be an automatic goal. Every partition has a number associated with it. It's a workable number that really keeps the partitions in logical sequence. I call it the bound. So this is what a non-partition table looks like. That's the top bullet there, where all the data goes in a single partition. That's exactly what that's today. When you have a table partition with our partition table with no boundaries, it also looks exactly the same. The only difference is you have the capability to add additional boundaries after that's created. And then that last the last third of the slide shows the table with 3 partitions. Now, there's a couple of points that there. First of all, in this case here, I have 2 boundary values. Basically, January 1st, 2013 and January 1st, 2014. Yet I end up with 3 partitions. That's something to always keep in the back of your mind. You're always going to have one more partition than you have boundaries. Because the boundaries go between the partitions, if you will. And again, the first and last partition, the lower boundary of the first one is as as the last boundary of the last partition of the table. So let's keep that slide in mind. Are there any questions so far? Please, table equipment. The partition function is a database object, and it's not schema scope, it's database scope. They don't like a DDL. It specifies the column data type, and that means that any table that you partition using this partition function have to have the same data type. It also specifies
aliens.
Ghosts, I guess. It specifies a range specification. Meaning you specify either left or right, and I'll show us a couple slides in a minute to make that a little clearer. But it specifies whether or not the adjacent partition, or which adjacent partition, I should say, includes that boundary. Range left is a lot of people think of that as a like a less than. I'm sorry, as a less than or equal to the specified boundary value, and right is greater than or equal to. But technically, it's really just the whether or not the left or right partition, when it's ordered, partition number sequence, which one actually includes exact matches on that boundary. And I'll show you why that's important to understand. So I mentioned a couple of those here. Yeah, the third bullet there, where it says the boundary side left or right determines the partition that's created when you do a split in the partition function. And I'll get into more details with CDL in a few minutes here. As well as the partition that that it gets dropped when you do a merge operation. So it's important is understanding which partition you're actually affecting here, because if you accidentally, obviously you don't want to accidentally drop a partition that contains data, because when you merge the partition, move all the data into the remaining one, that can cause a lot of data movement. Something you try to. Similarly, when you're splitting a partition to create a new one, you want to try to avoid data movement as well. It can be a little bit of a bind if you're not familiar with partition. That's why I want to explore some of these gotchas. If you have trust me, if you accidentally split a partition on the table, create a partition, and it's got billions of rows in it, if you don't specify the boundary correctly, it can take quite a while to move all the data. And I mean more than quite a while. It's about 4 times as much logging as a regular DDL or PML to do a partitioning at the field. So it's definitely something to try to do. That bottom bullet is something a lot of people aren't aware of, but you can't ever drop the first partition of a range left and the I said backwards. The last partition of range left and the first partition of range right, and that's simply because you got to always have at least one partition in your table. And the way you identify that partition, as I mentioned a little bit above, is the left or right. And the partition that includes the boundary value is the one that's affected. So here's an illustration of the actual create partition function DDL, where the 3 main components are the besides the name of the partition function itself, is the data type. In this case, I'm using a date time 2, position 0. Just as an aside, a lot of people still use date time, even in the SQL 2008 later versions. Date time 2 takes up less space, it's more flexible, and gives you more precision. So I strongly recommend that you use date time 2 going forward to develop if you have a specific to not to. Plus, date time has a nasty habit of rounding milliseconds to the next 30 seconds. And it's just a little. So in this case here, in addition to the data type, I have a range right specified, meaning that the partition on the right is the one that's inclusive. And I have two boundary values specified. So with those two boundary values, here's the range right. The second partition will have the value that exactly matches that January 1st, 2012 date. And the next, second, then the last partition, partition 3, includes the boundary value that matches that date. So that's effectively what that partition function is the range right. Now you can also do range left partitioning. After playing around partitioning for several years now, I've decided I don't have to use range left anymore, but I'll show it. And unfortunately, range left is the default. I think Microsoft made a mistake, frankly. I should have done that. But anyway, that's my for now. And here's why I say that. Here's the exact same scenario with the range left partition. It has the exact same boundary. In this case, the first partition has anything that's less than or equal to January 1st, 2012, midnight. And the second partition can be applied. It's really just the same as before. The only difference is the boundary value inclusive on the left partition. The surprise gotcha here you might not notice at first glance is that usually when you're partitioning by any sort of date or date time, you want all the data for a given date in the same partition. So this example, let's say I have a date of January exactly, January 1st, 2012. That will get put in the first partition, just fine and dandy. Except if I also have a row that's January 1st, 2012, 1 second after midnight, that one's going to get stuck in the second partition. So it's not really where I intended to place the data, usually when you have a date time. So that gotcha occurs anytime you have a any data type that includes the time component, date time. So just be advised that it's especially important that you use things right. That sort of right. Like I said, I don't think it's really a good thing to do a range left, because I haven't found it. So the purpose of the partition scheme is to really just map, file partitions to boundaries. And just like a partition function, it's also a database level. The number of file groups is always one more because the number of partition boundaries they have specified in the partition function, simply because there's a number of partitions is one more number. So you always have that many listed. Although SQL Server does allow you to specify one more partition, one more file group listed on the partition scheme. If you do that, automatically assign it to the next use file. I'll describe it in more detail. But it's not actually used to map the partition immediately. Wait until create a new partition. And the last bullet there is how you use the partition function, and really how you partition a table or index. Is that you just specify in the on clause, instead of specifying boundary, you can specify the name of the partition scheme, as well as the data, the actual column name that you want to partition, and that will partition that table for index accordingly. So you actually create the table for index. That's when you do this. This relationship is a little bit tricky, but you can have multiple partition schemes that use the same partition function, and that's really not too uncommon. However, people that have done partitioning for a while have found that's kind of dangerous too, because what that means is that anytime you modify the partition function, you're really modifying all of the partition schemes that refer to that function. And furthermore, you're modifying every single object that refers to those. If you create a new partition, it'll have a cascading effect on all of the underlying partition schemes and objects. So that can be a good thing or a bad thing. It can simplify your maintenance and stuff, but at the same time, you need to really be aware the implications of that cascade. So, especially if you're relatively partitioning, I would suggest that you try to stick with just one partition scheme per function. And whether or not you use that partition scheme on multiple tables, I would suggest against it, except for the scenario I'll describe, staging table. One of all two partitions at the exact same time. So here's what the partition scheme DDL looks like, or can look like. One example is where you just have a list of your partition schemes. In this case here, my purpose is to partition by year, so I have one file, per year. You might notice that because this is a range right, you can never delete that first partition. I just kind of gave it a generic name, archive file group, and my intent is to always keep that empty. In other words, I'm never going to have any data that's holding, that first partition boundary. Furthermore, I named subsequent file groups according to actual content. So this is, I'll go on and describe the next one too. Okay. You can also, specify the clause that's where it says all to again one file group. And that means all the partitions use that one file group that they didn't specify. In this case here, I just use the default key so that all partitions get raised from the default file. The database can have one file group marked all. And just as an aside, when I create a database, I always create, of course, you got to have a primary file. That's where your main, data file is, the MDF, the primary data file. But I just leave that guy alone. I never create any user object. I always create a separate file for at least one file for everything else. And typically that's where I'll stop, is that data file, user-defined data file. Now I'm marked that with full. And the only time I deviate from that is if I have a specific reason to do other things, which is to say I want multiple file groups because also I have, some of the data has a different, RTO. So you could do a piecemeal restore current data first, and then work your way backwards after that. That would be this case for having multiple file groups. But unless you've also gone through all that effort of segregating the storage of these different files, really not going to get a whole lot of benefits by the file groups unless you have a specialized use case.
Dan, is there a reason why you don't like to use just the primary file group?
Yeah, the question was, from Julie was, is there a reason I don't like to use just the primary file group? The main reason is to facilitate easy that way I can get basically the database online just by restoring the primary. And then, which of course also has the MDF file. And you can't start up your database without the MDF file. You can theoretically without the other file. And chances are you've added them, if you use a single primary file, you probably have MDF files arrays and that kind of stuff. So anyway, that's my editorial opinion. You can always take it or leave it. The one way one creates a new partition is with the alter partition function statement, and there's a split clause. There's actually three clauses: split, it's also two clauses: split and merge. Split creates a new partition, and merge moves the partition from the function and all the associated partition schemes and boxes. So when you do split a partition function, it first determines which partition contains the specified boundary value. Let's say you start with a table with no partition, well, that one partition is going to contain the value, and then it adds the partition boundary to the partition. And as needed, we'll go on the rows from the split partition into the new one according to the new boundary. So if you have a a lot of data in that partition that you just split, it's going to have to move all of the data into that new partition to match the new boundaries. And as I mentioned earlier, it's a very expensive operation. For that reason, it's a really good idea to make sure your plan is to split only empty partitions as possibly can. There's a little bit of a caveat to that, so you can still split a non-empty partition. You got to be really, really careful that no data needs to be moved in the process, or it's a little painful. After it creates a new partition boundary, I'll add the data. It then renumbers the partitions according to the boundary. So that's a little bit confusing because, especially if you're doing a range lev, or I'll show you. But it is a little bit tricky. And then it, I forgot to mention, it also modifies the it also modifies, this isn't exactly a sequence, but it modifies the partition scheme to add the next use value to the actual list of boundaries. So before you actually do a split, you first have to add a next use value with all the partitions that you set that partition.
So what type of locking happens at the table level and partition level, while if you have data in it and you're splitting it?
So the question was about locking during the DDL operation, splitting the partition. It's a schema modification lock, which is good, but then again, it's bad because you can still run into some nasty deadlocks. That's a common problem. I used to have that when I first started using partitioning. What I did to address it is I grabbed an exclusive table lock in the partition maintenance script so that there's no other concurrent activity that can hit that table during maintenance. Now, the good news is that splitting the partition, as long as there's no data movement required, can be nearly instantaneous. But if you have concurrent activity in the table, you can run into deadlocking and things like that during the maintenance. So I suggest that you require to do that in the maintenance time frame when there's a little bit of concurrent activity on the table.
The whole idea of partitioning is to limit your changes and impact to one partition. So why would you put a lock at the table level, not just a partition?
The question is then why you could put the lock at the table level instead of the partition level. Because the DDL operation is for the metadata that applies to the entire table, not a specific partition. So if I don't lock the entire table, there's multiple partitions that are affected, for example, by a split. There's also multiple partitions that are affected by merge, because you're combining two partitions. So there's no way, at least that I get an exclusive lock on just those partitions that are affected. At least exclusively. So an important point is before you do the split, you have to have a next use file group for all of the affected partitions. And that next use file group really just determines what the file group is that partition gets created. So make sure you set up your file groups correctly. And again, I can't emphasize this enough because this is important. The new partition is the one that contains the new bound value. If we're sticking with range right, the bound is going to be different. So here's an illustration about what happens when we split a partition function. In this case, and I'll assume that there's underlying partition schemes that I haven't detailed on the slide. So we start by just creating a partition function I don't have any boundaries specified, so it's a single partition that contains all the data. Then if I split that partition, specifying, date as, January 1st, 2012, first thing it'll do is it'll create split that existing partition into two, to accommodate that two date boundary. And note that the new partition is the one that is created on the right, the first one, partition number 1. This is basically where all that data is. And then it'll involve data that is greater than or equal to January 1st, 2012, to that second partition that I just created. And then finally, it'll renumber the partition, the original, this is also the partition, I'll renumber the partition 2. So if we do the exact same thing with the range left, and this is one of the reasons I like to avoid left, using same exact scenario, same exact boundary, no difference is to range left. Now I created a boundary. It creates it to the left of partition number 1. So, the partition, like instead of on the right. But now it has to, move all the data just like it did before. But then it's kind of confusing because then the new partition becomes partition number 1, and also the old partition number 1 becomes 2, etc. But either way, it's going to have to renumber the partitions, that are great, the ones that are great. So, it's not, again, like I said, I just find, especially when I do like queries, I look at the partition, do the split, and then I get confused because partition numbers change and stuff like that. It's a little bit on the confusing side. The merge just drops the partition. It doesn't actually delete any data. It just drops the partition by merging it to the adjacent partition. So, like I mentioned earlier, it's really important to understand which partitions you're keeping and which ones you're going to. So it'll really boost the boundary value and merge the rows, to the partition that has not been dropped, the adjacent partition. We only was bound between two partitions here. Remove the boundary from the function, and then finally remove any of the values that were listed in any affected partition for the drop partition, unless it's already being used by another partition. It's still in the list, but it's a different partition. Furthermore, it won't drop it from there next to each file.
Is there any risk of losing any sort of data with any other DDL operations here?
The question was, is there any risk of losing data with these DDL operations? Not with the ones I've listed so far. I'll get to that in a minute. No, merge will always keep the data as it's split. The only issue there is there will be some pain if you do that against a non-empty partition of any considerable size. So, as I mentioned earlier, anytime you modify the partition function to a split or merge, you will modify all of the dependent partitions to an object. So, be advised. So here's an example of what happens when you do the merge. Here in this example, we'll start with a table that has two partitions, aka one boundary. And when the boundary gets removed, then it has to, in this case here, it's a range left. So I'm basically saying I want to, drop the first partition. And then have to empty it, moves the data and empties it out. And then after that, of course, there's a number, so partition 1 out, all single boundary at table. And the range rises for example. The difference is, of course, it goes the other direction. When it comes to data. So here's the fun part, where it really can do some work besides just, change the boundaries around. And that's switch. Switch is really what a lot of power partitioning is when it comes to being able to do a couple of different kinds of things. Because what switch does is it moves not copy an entire partition or entire table, in the case would be, to another separate object is a metadata operation. So that means literally you can billions of rows from one table to another in, just a few microseconds. I'll say milliseconds, maybe not microseconds. The source and target tables, they switch from to have to have absolutely identical scheme, meaning that all the data types have to match exactly, same whole 9 yards, because it's only messing with data storage metadata allocation. It's not actually, considering the scheme or anything like that. It's not like an insert statement where different mappings, columns, stuff like that. It's actually